Okay, the last one that I wanted to look at here before we started working on some homework is it's a review problem in this sections 3, 4, and 3, 5, and it starts off with what is the initial position of the particle. So the initial position of the particle is when t equals 0. So when t equals 0, then the position at 0 would be equal to 2. Now, for part B, what is the initial velocity? Well, that's going to be the derivative. So that would be negative 2t plus 1. When is the particle moving to the right? It's going to be moving to the right whenever the velocity is positive. Okay, so if I make a little chart like this, we know that this is going to be at t equals 0.5. At t equals 0.5, the velocity will be 0. So t equals 0.5. And then now, whenever t is greater than 0.5, whenever this is going to be greater, then the velocity will be negative. But when t is less than 0.5, okay, when t is less than 0.5, then it's going to be positive. Okay, and then for part D, find the acceleration. The acceleration is going to be the derivative of this, so this should be negative 2 meters per second squared. And then letter E is find the speed of the particle when the position is 0. So we need to find the speed, and the speed is going to be the absolute value of the velocity when the position is 0. So I'm going to take that first equation we're given, and I want to know when that's equal to 0. I'm going to factor out that negative here, and when I factor that, I can factor this as minus 2 and then plus 1, and this gives me t equals 2. So at t equals 2, that's when I want to find my speed. So the speed is the absolute value of the velocity. So if I plug that in to my velocity function, I'll get negative 3 for my velocity. And since speed is the absolute value, that means that my speed would be 3 meters per second.